to discuss the formal definition of what is a game and game theory. So what is a game? Game theory. So game theory is basically a systematic study of strategic interaction. You can see this is very important. Systematic is a strategic interaction among rational individuals or the rational players, I would say. So there are two heavy terms in this definition. First, so strategic interaction, and third and second point is among rational players, rational individuals. So what do you mean by strategic interaction? So strategic interaction, so that individual act has to be strategic, that they should be, we say the act is strategic when they are aware of the fact that the action affects other. By strategic interaction, we mean that individual know that the action will have effect on outcome and act accordingly. Only if individual, the player, is aware of the fact that his action will have an effect on outcome and then he act accordingly, then only that action is called strategic action or the strategic action. So what is a rational? So rational in this case is an individual or the player, it may be firm, it may be consumer, it may be government, is a rational if he or she has a well-defined objective. It may be, in case of firm, it may be maximization of profit. In case of consumer, it may be maximization of utility. In case of government, it may be maximization of tax revenue. Over the all set of possible outcomes, and she implements the best available strategy to pursue them. So basically, being rational means you have a well-defined objective, pursuing your objective such that you are able to fulfill your objective. You are able to maximize your objective function. So these are two. What is strategic? And a strategic interaction among rational players. So the game theory is also a formal study of, it's a formal study of a conflict and cooperative situation. So game theory concept apply whenever the action of several agents are interdependent. This is very important. Whenever the action of several agents are interdependent, these agents may be, or the players may be, it may be individuals, groups, firms, or any combination of those two. So there are certain definition which we have to be very clear whenever we are going to deal with game theory. First is this, what is known as first, any game will have these components. One is a player, set of players, any game, whatever form it may be, set of players who have a set of strategies, players having set of strategies, and after once you have implement those strategy or choose those action, you have a certain payoff. Payoff means the outcome which you give by choosing that particular action. In the case of firm, the outcome may be the profit. In case of consumer, it may be the final utility. So what is a player? A player is an agent who makes a decision in a game. So those player may be an individual, consumer, it may be government, or it may be a firm. So what is strategy? As I've already told, in a game, in a game is a strategic form. A strategy is one of the given possible action of a player. So strategy is basically one of the given possible action of players. In an extensive form, a strategy is a complete plan of choices, one for each decision point of the player. So let us I would say rather concentrate in this point, that strategy is one of a given possible action of a player. So a player, we have multiple option of action. So strategy is just one among those action. So by choosing, if player chooses those strategy or chooses those action, he gets certain payoff, and this payoff is called utility. It reflects the desirability of an outcome of a player for whatever reason. When an outcome is random, payoff is usually weighted with probabilities. So let me tell you, the player can choose the action with absolute certainty. When player chooses the action with certain 100% certainty, then we call those strategies the pure strategies. And when player chooses a strategy with certain probability, then we call it mixed strategy. Mixed strategy, there's a basic difference between pure strategy and mixed strategy. And one more very important definition is what concept which is required in a game theory is like what is known as a common knowledge. So what is common knowledge? A fact X can be anything, is a common knowledge if everybody knows it, and if everybody knows that everybody knows it, if everybody knows that everybody knows it, and so on. So in this case, common knowledge is an assumption on part of the kind of knowledge which player possess about the entire game. So when we say anything is a common knowledge, in that sense, player knows the entire outcome of the game. So in that sense, and the same thing is also known to the both players. So after introducing this concept, the main components which are usually there, we'll move to certain strategy or type of strategy. One strategy which we have already discussed in discussing one form of game is called dominating strategy, or the one way to solve the game is called dominating strategy. So what is dominating strategy? A strategy dominates a strategy dominates another strategy of a player if it always gives a better payoff to that player regardless of what other players are doing. It weakly dominates the other strategy if it is always at least as good. It is at least as good. So what is another point is a rational player will never choose to play a dominated strategy. Third point is that there is no optimal choice of strategy for each player, no matter what the other player does. So let us take a two case. So in extreme case, if a player has only two strategies, strategy A and B, so in that case, given any combination of strategy of other player, the outcome resulting A, if outcome resulting A is better than the outcome resulting from B, then we say strategy A dominates strategy B. Let us go to our first game. In this case, in a pandemic game which we have set up in this case, let us check the strategy of government. Either it's a make compulsory or don't make compulsory wearing masks. By making masks compulsory, irrespective of what citizen does, whether they wear a mask or not, the government is getting higher utility or the higher payoff than with respect to this strategy, which is making marks wearing voluntary. So in this case, instead of 50 you get 100, instead of 10 you get 10. So in this example of pandemic game, what we can say for government, at least for government, making wearing masks compulsory is a dominant strategy, and wearing masks is a dominated strategy. So as I've already told that any rational player will never play a dominated strategy. This is a dominated strategy, and this making compulsory dominates this strategy, because by choosing making compulsory, irrespective of what other player does, it always gets higher payoff. In this case, instead of 50 it gets 100, instead of 10 it gets 50. So for government, making wearing a mask compulsory is a dominant strategy. So it will never. So this is a dominant strategy. Since making marks wearing voluntarily, is a dominated strategy. It will never choose. So government will never choose this outcome. So then we go to other concept, which is a concept of Nash equilibrium. So what is a Nash equilibrium? A Nash equilibrium is the most important equilibrium concept of a game theory, I would say. And it's the most widely prevalent idea which is used in game theory. So what is the formal definition of Nash equilibrium? A Nash equilibrium, also called strategic equilibrium, is a list of strategies, one for each player, which has the property that, so Nash equilibrium is a list of strategy for both, one for each player, which has a property that no player has unilateral change. No player unilaterally changes his strategy and gets better payoff. So no player, if both player reaches a Nash equilibrium, no player have an incentive to deviate from that equilibrium. So another important assumption which is required to derive Nash equilibrium is this. So Nash equilibrium is based on the premise that each individual acts rationally given a belief that other players' action. So each player has to act rationally, which means he has to maximize his objective, assuming that other players' action. And the other part is that these beliefs have to be correct. That if I'm assuming that he is choosing his best, in that sense, in some sense, this assumption has to be true, and I have to choose the best among my strategies. So once every individual is acting in according to Nash equilibrium, no one has incentive to unilaterally deviate and take another action. So another way of viewing Nash equilibrium is that Nash equilibrium is a set of choices for which each player choice is optimal Each player's choice is optimal given the choice of other player. A pair of strategy, it's a formal definition. A pair of strategy is a Nash equilibrium. Let us say there's a two players, A and B. If A's choice is optimal given B's choice, and B's choice is optimal given A's choice. This is a very intuitive way of remembering what is Nash equilibrium. And the problem with Nash equilibrium is that it many times you can have in the same game you can have more than two Nash equilibrium. So Nash equilibrium may not be unique. The other part is that in some games of Nash equilibrium you may not have the Nash equilibrium may not exist at all. At least in pure strategy. In mixed strategy you can have those solution. So let me go to one example of Nash equilibrium. So in this case, in the case of the oligopolistic, the decision of two oligopoly, Starbucks and SF Coffee, San Francisco Coffee, to whether to advertise or not advertise. In this case, you see, advertise for SF, advertise for Starbucks is a Nash equilibrium because if for what is the best thing for Starbucks, if SF don't advertise, what is the best thing for Starbucks to do is to advertise and get 20. If SF advertise, what is the best thing for Starbucks to? In this case also it is to advertise because by advertising it gets higher profit than instead of 10 it gets 12. So let us check the what is the best thing for SF Coffee. If Starbucks chooses to not to advertise, in that case what is the best thing for SF to do is to advertise. By advertising it gets higher return than instead of 50 it get 20. If Starbucks advertises, what is the best thing for SF to do is to advertise, and by thereby getting instead of 10 you get 12. So for both players, in this case both oligopolies Starbucks and SFC, the best thing for them to do is to advertise. And if assuming that the other if Starbucks advertise, the best thing for Starbucks Starbucks is to advertise, assuming that the best thing for SFC is to advertise, and the best thing for SF is to advertise, assuming that Starbucks, the best thing for Starbucks is to advertise. So in that case, 12, like choice is like advertise is a Nash equilibrium of this game, of this strategic form game. So now we have discussed Nash equilibrium. Let us go to a type of game. So game theory, you can divide game according to various criteria, according to the way the number of players, the kind of information which a player possesses, even the kind of interaction which it has. So, but dominantly we can divide game theory into two parts. What is a cooperative game and other part is a non-cooperative game. So what is a cooperative game? So basically the cooperative game involves, rather than individual, it involves a group or what is known as a coalitions. So what is coalition? A coalition game is a high description specifically only applying to what pays off each potential group of coalition can be obtained by cooperation of its member. What is not made explicit in the process by, though it's not explicit how the coalition forms. So the cooperative game theory investigates such coalitional games with respect to the relative amount of power held by various players and how successful coalition should divide its proceeds. It is most naturally applied to situations arising in political science and international relations where the concept of power are more important. So the distinct feature with a cooperative game is it's usually not, it's paid between two groups, and then we move to other type of game, which is the dominant form of game which we are going to study in this course, is what is the non-cooperative game. So what is non-cooperative game? Non-cooperative game is concerned with the analysis of strategic choices. The strategic choices which we are discussing for government, like it's either to make marks compulsory or not make it voluntary. For a citizen, it is like either you choose to wear a mask or not to choose a mask. For Starbucks, advertise or don't advertise. Even for SF Coffee, advertise, non. All of these are kind of strategic choices. The paradigm of non-cooperative theory, non-game theory, is that it details the ordering and the timing of player choices are crucial determining the outcome of game. So cooperation and often does arise in a non-cooperative model of game when player find it in their best interest. So this is very important. Non-cooperative game does not mean that there will not be any cooperation in non-cooperative game. If uh, if it is best for, if both player finds in the best interest is to cooperate, they will cooperate even in non-cooperative games. So other form, it's this is more of a this division of game is more in terms of how do you represent a game. One is what we call the normal form game or the strategic form game, which we have introduced in the previous example. So what is a normal form game? A strategic form is a basic type of game studied in non-cooperative game theory. A game is a strategic form list each player's strategies like advertise, don't advertise, wear a mask, don't wear a mask, and the outcome that result from each possible combination of choices, the different payoff. In different cells, we have a different payoff. And the outcome is represented by the separate payoff for each players and the number that measures how much the player like the outcome. So this is an example of a strategic or normal form game. You have a list of strategies, and if you choose different strategies, have different payoff outcome, different numbers. This is also a normal form game. This is also a normal form game, the strategic form game, but this is of a different kind of game, which we are going to discuss. And now the other part of game is what is known as an extensive, or the form of game is an extensive form, also called game tree. It's more detailed than the strategic form game. It is a complete description of how the game is played over time. So think of normal or strategic game is like a one shot of point at one point of time. And extensive form game is a game which is played over the period of time, over the sequence of time. It is a complete description of how the game is played over time. This includes the order in which what is important is the order in which the player take action, the information player have at the time they must take those action, and the time at which any uncertainty situation is revolved. A game in extensive form may be analyzed directly, can be converted into equivalent strategic form. So extensive form game of the game tree is this. This is an example. This is an example of extensive form game of the game tree, where there's a choice. Both players, there's a sequence of choice in a sense that both players don't choose the action simultaneously. Rather, they choose it sequentially. So the entrance in this case, imagine either it enters or stays out, and after observing this choice, the flip card, the incumbent have to decide whether to fight or not fight. So other part of game is what is known as a constant. You can say it's also one way of categorizing a game. So whether you have a zero-sum game or non-zero-sum game. So what is a zero-sum game? A zero-sum game is a type of a constant sum game in which the sum of outcome of all players is zero. So basically zero-sum game is this. One player benefit is equal to other player's loss. That is a basic crux of zero-sum game. So if you add the benefit of both player, it should equal to zero. So what is a constant sum game? Constant sum is a game in one which the sum of the outcome of all player remain constant even if the outcomes are different. So across different outcomes, different strategy of choice, if you add the payoff function, it should equal to a same number. It should be equal to a constant. So what is a non-zero sum game? In non-zero sum game, in which the outcome of two players are not zero. So let us go to our example. So this is an example of non-zero sum game, because if you add those payoff, it's 15, 15, 30, 15, 20, 30, 50, 20, 10, 30, but 12, 12 is 24. So that's why it's not a constant sum game, because different strategy, if you add those payoff function, even though in these three cells you have 30, but in this case it's 24. So that's why it's the example of non-constant game, and definitely is not a zero-sum game, because if you add these two payoff 15 and 15, it's not adding up as a zero. So that's why it's a non-zero-sum game. So one thing which we are going to, one very special kind of game, I would say, like is which we think is very important, is like what is known as a prisoner's dilemma game. So prisoner's dilemma game, we have already solved prisoner's dilemma game, but it is a more of a very generic form of a game, and it's a very popular game which is widely used. So let me give you the example. This is an example of prisoner's dilemma game. This is a prisoner's dilemma game. So what happens is, like, in a prisoner's dilemma game, you have two prisoners. So two prisoners, instead of a Starbucks, you have two prisoners, prisoners A, prisoner B. And instead of these advertise, no, don't advertise, they have two choices. One is to confess and one is to deny. So situation of this game is this. So both of these players, are in some sense, the criminals, they have committed a crime. Maybe they have robbed a bank. But the advantage is that police don't have any evidence against them. Until unless both of them confess or one of them confess, the police are forced to let them free. So in this situation, let us take this number instead of this dollar. Let us take the number of years in which they have to remain within jail. So or you can say that, we can say that. I think it will be a bit confusing in this case. So let us say don't advertise. So don't advertise is like the other part is like if the police will give both prisoners are brought in one room and the police give this choice. If both will confess, let us say this is like instead of advertise, let us say confess. If both confess, they'll get less jail time. So it's just 12 years jail time. 12 plus jail time. If both deny, this is a deny. If both deny, I think they should get less jail time. So in that case, let us say this is not a jail time, this is a utility. So since they are getting less jail time, so this is a higher utility, 15. If both of them confess, they get because both of them confess to a crime, they will be sent to jail and utility will be less, 12. So the most interesting case will be between this. If one player confesses, in this case, this is a confess, and other one denies and other confess. If he denies and he confess, so he will get a higher amount of utility, because in this case one who is confessing will get less jail time and one who is denying will get higher jail time, so lower utility. Same in this case. If prisoner 2 confesses and prisoner 1 does not confess, in that case prisoner 1, since he is confessing, he will get higher utility, and prisoner 1 will get lower utility. So what is the outcome of this game? The outcome of this game will be both prisoner to not advertise, both to confess, because they are not sure what the other player are going to do. So best thing is to confess and get 12 years of 12 level of utility. So though it's not very precise, I'll definitely discuss in next lecture. I'll definitely discuss a very neat form of prisoner's dilemma, because I don't think it's very clear in this example. So the last part which we are going to do is what is known as a let us take this one. Let us take this game where you have a customers who have two choices. In this case, you have a customer. Either they buy a service. In this case, let us take an internet connection. And maybe you're taking a new mobile connection. So a 4G connection, maybe a 5G connection. Either you buy a service, you don't buy a service. If on the service provider, it may be a Vodafone, it may be Jio, it may be Reliance, it may be Airtel. It can either provide high quality service or low quality service. So let us check the payoff function. So if Vodafone or the Reliance or the Jio provide high quality service and customer buys that product, in that case Jio will get 2 unit of utility, other profit, or we can say payoff, and he will also get 2 unit because the even customer preferred to buy a high quality product. So even he will get higher utility, in this case 2. But if he buys a product but the company offers a low quality service, in that case company earns revenue because the customer has bought that product. He will get 3 unit of profit, but the customer utility will be 0 because he is getting low quality service. So let us take examine another side of payoff function. What if consumer do not buy a service? If consumer do not buy a service but still government the service provider, in this case the Reliance or the Vodafone, provides a good high quality service, he will earn 0 profit. But since he is not buying anything, so he'll get higher, since He's not buying anything, so his utility will be less. In this case, it will be just 1. What if he is not buying, consumer is not buying, but the company is providing low quality service? In that case, both company and customer will get 1 unit of profit, because anyway consumer is providing low quality service. The service provides low quality service, and he is not buying it, so both get less amount. If you closely observe this game, for at least for the service provider, playing high, if he plays high, irrespective of what it will see, it will get 2. If he buys, it will get 0, 2, 0. In low, it gets 3, 1. Since 1 is greater than 0, 3 is greater than 2. So low dominates strategy high. So for this firm, they always prefer to provide low quality service. But knowing that the firm will always provide a low quality service, what is the best response for buyer will be to don't buy. If he buys low quality, he gets 0. Instead of getting 0, if you don't buy, it get 1. So the solution of this game will be that the firm will provide low quality service and the buyer will not buy the service. So it's like low, don't buy, and buy, thereby firm getting 1 unit of its payoff, or the utility or the profit, and the consumer getting 1 unit of utility in this case. So this is the outcome payoff. The Nash equilibrium in this case will be low and don't buy. So what if, let us take another way. What if it goes other way? What if firm chooses to provide high service? In that case, what is the best response for buyer? It will be to buy, because if he buys, he gets, instead of 1, he get 2. So what is the best response if consumer, if he provides low service, the best response will be to provide. Best response for him will be to not buy. So what is the best response if he buys this product? What is the best response for the company? It's to provide high, thereby earning. It's to provide low service, because by providing low service, he earns higher utility or higher profit than providing high service. So in this case, we can say that even by using a dominated strategy or by Nash equilibrium, the best thing for him is to get 1-1, provide low service and don't buy it. So this much for today's lecture. And next lecture we are going to discuss in a very detailed way, in a much more strategic way, what is known as maximum strategies, and we'll also introduce what is known as a payoff matrix. And the other part is the idea of saddle point and how to solve it. So thank you so much.